Welcome! In this session, I will install and look at an R package for comparing two samples where there are both paired observations and independent observations within each of the two samples. Firstly, let me import the dataset that I have saved as a .csv file in my working directory. So if I go to Session, Set Working Directory, choose Directory, and I will select the destination where I've already saved my .csv file. The file was saved as marks.csv. So now that I have set the working directory, I will read in the dataset marks.csv. And I will assign it to a data frame, an object, just so that I can call up that data in the console when I need to. So you can now see in my environment, I have some data called my data, 7 observations of 3 variables. So let's have a look at those variables. What you see here is some exam marks for 2 modules, one module called StatMod and one module called MathMod. You will also notice that the first 4 observations are paired, and the final 3 rows of observations are all independent observations. So just as a quick summary of the average of the 2 modules, StatMod and MathMod. To get the mean, for example, using the function mean, well, here we want the mean of the data frame, which we called my data. And from that data frame, my data, well, we want, first of all, the average StatMod mark. So using that $sign says call up from the data frame, my data, the variable StatMod. And for completion and for interest, let's compare that to the mean for MathMod. So it looks like the average score for the statistics module is higher than that for the maths module. Is it significantly different? Well, perhaps we can do a formal statistical test to see if it is significantly different. Some of those traditional tests you may have seen, the paired samples t.test, wouldn't quite be appropriate here because we're saying that only 4 rows of data consist of students that took both the stat mod and the math mod. Likewise, independent samples t-tests may not quite be appropriate because we only have 3 rows of data that did either the statistics module or the maths module. One technique for comparing these two samples is known as the partially overlapping samples t-test. The partially overlapping samples t-test is not a standard test available in the base R stats package. So I will need to install an additional package. A quick search on any well-known search engine indicates that there is a package called partially overlapping, which may assist with performing hypothesis tests. So it's case sensitive, and it starts with an uppercase P, the package partially overlapping. So let's install this package using the function install.packages. Now that it's been installed, in order to work on the package, you will need to call it up from the library. So installing the package is something you should only need to do once if you're continuing to work on the same version of R in the same folder. But each time you start a new session, you may need to call that package up from the library. So from the library, I'm going to call up the package partially overlapping. At this point, it's probably worth having a look what exactly is in this package. So to bring up the help file on the package, I can do question mark partially overlapping. And now you can see I have partially overlapping 2 possible tests. The partially overlapping samples t-test looks like the one that would be of interest to us. And you can see that within the package partially overlapping, the function will be called Partover.test. So we can go into that help page, and we could have found this help page also by simply going question mark Partover.test. Now we know what the function is called within that partially overlapping package. So let's have a look at this help file for the partially overlapping samples t-test. There's a brief description of what it does. And it's often good to read these brief descriptions because it gives you some clue as to the usage of the test. So you might be able to work out what we need to feed into R in terms of the function from just looking at this usage. But sometimes you need to do a bit more further reading of the description and what the different arguments are. Because for in this case, where we have two variables, StatMod and MathMod, and you might be looking at this and thinking, well, here it's actually requesting potentially 4 variables, x1, x2, x3, and x4. So why might that be? Well, looking at the arguments here, x1 is a vector of unpaired observations in sample 1. x2 is a vector of unpaired observations in sample 2. x3 is a vector of paired observations in sample 1, and x4 is a vector of paired observations in sample 2. So that explains why there are 4 separate vectors going into this Partover.test. The rest of this test is similar in terms of usage to if you have done the independent samples t.test or paired samples t.test before, default two-sided test, testing for equal means. So all of that we can probably leave as it is. So in order to get the data into a format that this particular function wants, we're going to have to split this out into x1, x2, x3, and x4. For simplicity, I will call them x1, x2, x3, x4, but you don't have to call them that. But x1 is going to be a vector of unpaired observations in sample 1. So the unpaired observations, let's say StatMod is sample 1, it's going to be 88, 56, and 92. And x2 will be 56, 66, 76. x3 there are ways in which you could do this in a more sophisticated way rather than typing in all the values again. It's a basic learning exercise. We will just type the values in here. Now I have the 4 vectors x1, x2, x3, and x4. I can now do the Partover.test. And as I called them x1, x2, x3, and x4, I can just put those straight in. Let's have a look at my result. P-value greater than 0.05. So at the 5% significance level, there is no evidence to reject the null hypothesis. And our null hypothesis would have been that there is no difference between the average StatMod exam mark and MathMod exam mark. So in this particular instance, we found no evidence to reject the statement that the average marks are the same for the 2 modules.